Okay, today we're going to be covering the second section of 1.4. So in this section, we are going to be discussing when you have an absolute value equation equal to another absolute value equation and how to solve it. So as this shows, when you have an absolute value equation with a variable inside equal to another absolute value equation also with a variable inside, then all you do is you start by setting them equal to each other without the absolute value signs, and then you do a second set equal to each other, but you make one side negative. So it can be the right side or the left side, it doesn't matter, but one side must be negative. So let's look at how we solve this first one. So we have this here, and we're going to start. The first part is the easiest part. It's where you just do 2m plus 5 equals m. So I just drops the absolute value signs. Now I'm going to solve this. I'm going to get all the variables together. There's multiple different ways to solve this, but I'm going to start with this. So m minus m is just 0. Don't just leave it blank, it is 0. 2m minus 1m is just m, and you still have plus 5. To get m by itself, move the 5 over, and so we find out that m equals negative 5, which if we plug back in and check, we do 2 times negative 5, that's negative 10, plus 5, that's negative 5. The absolute value of negative 5 is 5, and the absolute value of negative 5 is 5, so it does check out. Now on this side, what we do is we do 2m plus 5, and then we make one of the equations negative. And if there's one that only has a variable and it doesn't have a variable plus or minus something else, I'm going to choose to just go ahead and make that one negative. So I'm going to start there. So this is showing right here where we made one side negative. And from there, I just solve as normal. So for me, I'm going to once again move the m to this side because I find it easier to do. Now 2m plus m is 3m. And you still have plus 5, and negative m plus m is 0, just like negative 1 plus 1 would be 0. So now I move the 5 to this side, so I come out with 3m, 5 minus 5 is 0, and 0 minus 5 is negative 5. Divide by 3, and my answer is that m equals negative 5 thirds, and n equals negative 5. So this one has two solutions, which you can use with your calculator to check back in and make sure they both work out. Okay, so extra example part B is something similar, except as you see, both equations this time have two terms, so they're a little bit more complex. So to start out, like I said, the first one's always fairly simple. You just basically drops the absolute value. Now, the 2 out here is multiplying times this entire equation, so we can't just put 2 4k. That would appear to be 24k. We also just can't put 8k because the 2 has to be distributed amongst everything in here. So I put the parentheses so that then I realize that I need to use the distributive property, and I take 2 times 4k, which is 8k, and 2 times negative 1, which is negative 2. So from here, I'm going to go ahead and I'm going to get all my k's on the same side. So I'm going to move the 5k over this way, so I'm left with 12. 8k minus 5k is 3k, and I have the minus 2. Now I'm going to move the 2 over here. The inverse of minus 2 is plus 2. So I have 14 equals 3k. I divide by 3, and so I just have k equals 14 thirds. Or if you'd like to write that as a mixed number and put 4 and 2/3, that would be fine also, but I'm going to go ahead and leave it as an improper fraction. Now keep in mind, over here, you still have to do the same thing where you have one side be a negative. So like I said, it doesn't matter which side. I'm going to go ahead and just make it be the right side because it's kind of a wash which way you go. So I'm just going to change that to be negative 2 because the negative will then go with the 2 through everything in each equation, which is what I want. So I'm going to simplify here. I still have 5k plus 12. Now I have negative 2 times 4k, that's negative 8k. And negative 2 times negative 1, that's positive 2. So once again, I'm going to move the k's to where they're on the same side. Doesn't matter which side you go with, just pick one. So I end up with 5k plus 8k, which is 13k, plus 12 equals 2. I'm going to move the 12 to this side. So I get 13k equals negative 10. And then once again, I'm going to go ahead and I'm going to divide by 13. And so I get k equals negative oops, sorry, wrote that wrong, negative 10/13. Now once again, this one has two solutions. I have 14/3 and I have negative 10/13. Now I'm just going to leave them just as improper fractions. They're already completely simplified, and I don't think writing them as decimals is going to benefit me any, or writing them as mixed numbers. So those are my solutions. And now if I want to come over here, and if I want to check them in a calculator, which is always a good plan, and you'll see why in a moment, what I'm going to do is I just want to find the number inside. So like I know it's 5k plus 12. So I'm going to sit here and I am going to do 5, and then my k was 14/3. So I'm just going to put in here 14/3 and then plus 12. So on this side, let's go ahead and do math fraction. On this side, I get 106/3. So I can sit here and I know when I'm checking it, that for this solution, I got absolute value of 106/3. Now, let's check what we get inside this other absolute value. So this is 4k minus 1. So I can sit here and I can do 4, and then remember, k was 14/3. So I'm just going to put it in parentheses and do 14/3, and I'm going to do minus 1. And of course, we'll math fraction that. And I get 53/3. So now if you think about this, this is already positive, so this is 106/3. This is 2 times 53/3, which works out to be 106/3. So this checks out. And then you can do the exact same thing over here, which just to save time, I'm going to tell you this one also checks out. So both of these are solutions. Alright, I'm going to leave all the monitoring progress on these pages until the end, so I'm going to do it as a separate video. So I want to encourage you, when you're done with this, to go ahead and try them without the video, and then come back and watch the video and see how you did. Alright, so some key vocabulary you need to know in this section is extraneous solution. Extraneous basically means extra or not needed. So an extraneous solution is one that doesn't actually check out and satisfy the original equation. So basically, anytime there is a variable on either side of the equal sign, if there's a variable on both sides, you must check your solutions, because your solutions may not all check out, they may be extraneous. So let's take a look at this one. This one, same thing, we're going to do two solutions. So we're going to start here, and we're going to set it equal to 6 in, and we're just going to solve as normal. So I'm going to move the 3 in over here, and I get 18 equals 3 in. I'm going to divide by 3, and I get n equals 6. Okay, so now I want to check this out. So what I'm going to do is I'm going to do 3 times 6 plus 18 in the absolute value, and see if it equals 6 times 6. Now I know 6 times 6 is 36. I can plug this into a calculator, 3 times 6 plus 18, and I end up with 36. So is it true that the absolute value of 36 does also equal 36? Yes, it is. So 6 equal n is a solution, and it does check out. Okay, so over here, we need to try the same thing. Remember, we need to try one side with a negative. So when it's just something like 6 in, not 6 in plus something, that's the one to choose. So I'm going to put a negative with that. So now I'm going to move 3 in to this side. So I get 18 equals negative 9n. I divide by negative 9, and I get n equals negative 2. So now we need to verify if this one checks out or not. So we're going to do the same thing where we plug in negative 2, and we're going to do 6 times negative 2 on this side. Right, that should be an absolute value. And so over here, I know right by looking at this that when I get 6 times negative 2, I get negative 12. And it is not possible for an absolute value to equal negative 12. If you go ahead and plug this into a calculator, 3 times negative 2 plus 18, you're going to get 12. The absolute value can never equal negative 12, so I'm going to throw this solution out because it is extraneous. It doesn't satisfy the equation. So this absolute value only actually has one solution, which is n equals 6. Okay, let's take a look at one more example before we move on to the monitoring progress. So same thing here. We're going to start out and we're just going to solve it with 2r minus 4 equals 2r plus 10. Now, I'm going to subtract the 2r's. And so when I do this, what happens is 2r minus 2r is 0, so they essentially drop out. Now, does negative 4 equal 10? No, it does not. So this one doesn't have a valid solution. but we still have to go ahead and try the other side. Now remember, when you put a negative on one of the sides, the negative has to go to the entire equation. So I'm going to put a negative and I'm going to put the equation in parentheses. That way I remember to distribute the negative. So I have negative 2r and then a negative 10. Now if we try to solve this one, I add 2r and I end up with 4r minus 4 equals negative 10. So then I add the 4 over, and I end up with 4r equals negative 6. So then I divide by 4, and I get r equals negative 3 halves, or if you want to put r equals negative 1.5, that's fine. So this also only has one solution. So if we go back in just to double check and make sure that it works, I would just put 2 times negative 3 halves minus 4. And I want to see what that is and see if it equals the same as 2 times negative 3 halves plus 10. Okay, so I'm going to get my calculator and I'm going to try that, because when checking your solution, you absolutely might as well just go ahead and use that calculator. So 2 times negative 3 halves and then minus 4. All right, that equals negative 7. So right over here, I can put negative 7, which we know the absolute value of a negative 7 is going to be positive 7. So we want to know, basically what we're asking here is, we don't know if this is equal, we're asking, does it equal? If it is equal, then it's going to check out. And if it doesn't, then we're going to throw that solution out. So let's try the right side. 2 times negative 3 halves, and then we're going to do plus 10. And we find out positive 7. So it equals the absolute value of 7. Now we know the absolute value of 7 is 7. Does 7 equal 7? Yes, it does, so the solution checks out. Okay, so I want you to stop and I want you to do on your note sheet, you have monitoring progress. You have number 8, 9, 10, 11, 12, and 13. So I want you to try those and see what you come up with. And then you can use the video and just zip right through it to check your solutions. Or if you haven't gotten them right, then you could stop and watch the solution and make sure you're understanding this. This is one of the hardest concepts we're going to do in Chapter 1. So I really want you to use your positive attitude and really work on improving your knowledge on it. Just with that growth mindset, I know that you guys can get this, and we will have a work day on it when we come back from the weekend. Thank you.